Hello. Today we'll be going over November 2016 Mathematics Paper 1 past paper. We'll be looking at functions. So in this following series of videos, we'll be looking at functions for paper 1 just to give you an idea on how to approach basic questions under functions. So let's start with this question 4. So it says that sketched below is the graph of h of x, which is equal to a to the power x. A is greater than 0. R is the y-intercept of h. The points P, 2 and 9, and Q, B, and 1 over h1 lie on h. So we can already tell from the notes at the top there that this is an exponential function, and since they've specified that a is greater than 0, even without seeing the function, it's the graph itself, we can tell that it's something like a concave up, something like this. Okay, that's a positive exponential function. And we also can see these points they've told us about. Q, it's on the second quadrant, fourth quadrant, I mean. This is on the first quadrant. And we have our y-intercept here, R, and then we have the x-axis, the y-axis. Okay, so we can get started with our questions. So the first question says, write down the equation of the asymptote of h. So the asymptote, let me just give you a brief explanation. The asymptote, when you look at your graph, for example, our graph is something like this. You can read the asymptote by looking at the graph or using the second method. I'll show you how. So you look at the graph, which point is the graph approaching slowly but not touching, right? So if you look, we can start this side. So this side, it just seems to be approaching infinity. It can go to any point up there. But this side, it seems to be approaching 0 but never actually touches 0. It just goes like this. So we'll never actually touch 0. That's theoretical. So you can say that so this x-axis, where it approaches, we know that y is equal to 0. So this could be, we can just write this as our asymptote, or horizontal asymptote. Or since we have been given that y is equal to a to the power of x, and plus q. This is the formula for an exponential function. This q becomes our horizontal asymptote. But when you look on the function we're given here, there's no q. So it means that q is equal to 0. Therefore, y is equal to 0. Right. So if you were given something like this, 3 to the power x plus 5, what would be your vertical asymptote? Without even drawing the graph, you can tell that your horizontal asymptote will be of y is equal to 5, right? So this q is your horizontal asymptote. Always look for that q. If it's not there, you don't even have to look at the graph, but you can look at the graph to confirm, right? So let's just remove this so we can get started on our questions. Okay. So you can go ahead and write 4.1. The horizontal asymptote for our graph y is equal to 0, right? And then we can write for 4.2. So 4.2 asks us to determine the coordinates of r. So they've already told us that r is a y-intercept of our graph, and we know from general rules that at the y-intercept x is equal to 0, right? Okay, so and r lies on h. We know the function, we know the formula for h, which is y is equal to a to the power x. X is equal to 0, substitute there, and then you get your answer, right? So let's just get to that. So we can just write y-intercept x is equal to 0, right? And then we have have y is equal to a to the power x. Just substitute 0. We know this is 1 from rules of exponents or exponential rules. Therefore, r, we've said that x is equal to 0. Why was that? So we got r. 4.3 says calculate the value of a. So now we want to determine the value of a, right? So we can do this by using substituting a point that we already know the coordinates for. So we have 2 points that were given. We have b, which is 1, we have q, which is b and 1 over 8, 1. We have p, which is 2 and 9, right? So this one, we cannot substitute this one because we will end up having an unknown a and unknown b. So we need these two so that we can have 9 here, 2 here, then we only have one unknown that we can solve for, right? So let's just go ahead and do that. So y is equal to ax. This is your h, right? So you sub point P 2 and 9 because it's on the graph. You have 9 equal to a to the power x. A to the power 3 because x is 2, sorry, because x is equal to 2. Therefore, you have something like this. You can write 3 to the power 2, just reduce this, a to the power 2. Same exponents, you equal the base. This is the exponential rule. An exponential rule, you can check it out. And then we have a is equal to 2. Some people may ask, why is it not plus or minus 2? That's another formula. From here, you can just write, you can just take a square root on both sides. And when you take a square root, you have plus or minus what? You have plus or minus 3. I see that I made a mistake here. Sorry about that. Yes. So this is just 3. So here we are already given that a is greater than 0. So you can just write this, a is equal to 3. So we just remove that minus because we are given that a is greater than 0, right? Okay, so we have determined our a, calculated a. So now they say this is a point such that dq is parallel to y-axis and dp is parallel to the x-axis. Calculate the length of dp. So we can, it always makes things easier by making sketches, like basic sketches make things much easier. So you can always sketch. You can just sketch your lines here. We have this is dp, and then we have this one here, right? Let's see, dq, right? So we start from dq, we go up to here and this, and then they say this is parallel to this, this is parallel to this axis, y-axis, x-axis, right? So we can first try by determining the coordinates for d. We can tell that this is b, so it's on the same x coordinate. We can just write b, and then this one's on the same y coordinate because we are given that they're parallel. Then we can just write 9, right? So since this is not on the graph, we cannot substitute 9 to get b, right? We have to use this value here that's on the graph to get b. Then we can just, it's the same b, right? And then since we have this, our objective is not to calculate the coordinates of d, but this whole length here. So we can do something like this. We know this is going to be 2 units because this is from 0 up to 2 because this is x is equal to 0, right? Here to here, we know this is going to be b units, right? But this b is negative because this is the 4th quadrant. So we can tell, we can just write down here that dp is equal to 2 minus b. So this will add up because b is negative, so this will turn into a positive, right? And then that's our formula. So now we have to find this. So let's just get started. as I already explained, that we need to substitute what is this, y over 81, which is a negative actually. It's a positive, sorry, 4.4. So we have this 3 to the power x. So you're gonna sub q, which is b, and 1 over 81. So can I have 1 over 81 is equal to 3 to the power b. This you can reduce it by using laws of exponents, and then you will have something like 3 to the power minus 4 is equal to 3 to the power b. You can also confirm that with the calculator. Then b is equal to minus 4. Another law of exponents. So you in this equation you have heard me say a lot about laws of exponents. So that means that they are essential to calculating to finding answers for exponential graphs, right, or functions, which makes sense, right? So let's just get started with this. We've already written the formula for dp, which was 2 minus d. So we know that this is 2 minus 4. Therefore, dp is equal to 6 units. This is what we have, right? So we can just write for 4.5. So 4.5, the question says determine the values of k for which the equation h into x plus 2 plus k is equal to 0. We have a root that is less than minus 6. So let's just revisit this. Let's go back to our equation, right? So it says that h of x plus 2. So this that we have, our original function is just h of x, but now you have replaced that x, right, plus with x plus 2. So you will have something like, instead of having this as 3x, you will have something like 3 to the power x plus 2. That's what you have, right? So when it says that your roots should not be less than what? We have a root that's less than minus 6. Actually, yes, your roots should be less than minus 6. You need a range of values of k, because a root that's less than minus 6 will be minus 5, minus 5.5, minus 4, minus 3. Any value less than minus 6, right? Oh, sorry. That is a common mistake. Saying that minus 3 is less than minus 6 is wrong, right? Because when you look at the positive values, that will be true that 3 is less than minus 6. But when you look at our number line, it does something like this. You have 0, and then you have 2. This is 4, 6. Here you have minus 2. You have minus 4. You have minus 6, right? The more closer you are to 0 from this side, the larger your number is, right? So minus 2 is greater than minus 6. But from this side, the further you are from 0, the greater your number is. So 6 is greater than 2, right? So you can say that our values increase when you go in this direction, right? So your value increases. So that means that minus 6, rows that are minus 6 will be around here, which are greater than minus 6 will be here. With the ones that are less than minus 6 will be at minus 7, minus 8, all of those values, right? So we go back to the basics. This is primary school math. You see, it can mess with you sometimes. You just realize, you just saw me do that you just saw it does that to me, did that to me. I mean, so let's get to this. So our roads, by the way, these are our solutions. You can say solutions, x values. Yes, x values consists of a function that's dependent on x, right? So we can say x values or solutions. So these are our roads. For example, b is your root, 2 is your root, right? So let's get started with this. Well, we now know what roots are. So let's just write this formula. And we now know what it means, that they should be less than minus 6. So let's get to that. H of x plus 2 plus k, which is equal to 0. You want to find k for which this. So let's just say that your roots should be less than 6, which should be around -7, -8, and that, and so forth. So you have 3 to the power x plus 2 plus k is equal to 0. Okay, so we can just find the solution for this before we look at that. So let's just do this. This is equal to, so we say minus 3 to the power x plus 2, right? So we want to find values that are less than values of x that are less than -6. So we want to find k values, right? A range. So that means that we'll have to get rid of this somehow. So we can say something like this: k is less than 3 to the power -6 plus 2, right? So let me explain why I did this. For example, let's say our root was 3 is equal to -6, right? We say that our root is 3 is equal to -6. So what kind of value of k will we get? We'll get that k is equal to 3 minus 6 plus 2, which is 1/81, because this will give us 3 to the power -4. And if x was minus, let's take something like 7, we'll get a k value of 3 to the power -7 plus 2, which is 3 to the power -5. This will be your 1/3 to the power 5. What is 3 to the power 5? Let me quickly do that. 3 to the power 5. This is, what is this? This is back to our table of multiplications of 3, right? 3 to, because this will be 3 by 3 by 3 by 3 by 3, and I just punched the calculator. This will give us 1/243, right? So we know that this is greater than this. So when k, we have 6 is greater than when you have k 7, right? Okay, and we want our x values to be less than this, right? So what we want our x values to be less than -6, right? And when we have less values that are less than -6, k values just they keep dropping and dropping and dropping, right? So it means that the value at -6, right, when we have values that are less than -6 now, then your k values become smaller and smaller and smaller. That's why we have that k is less than -6, is less than to the power -6 plus 2, right? Because here this is x is equal to 6, but when you have values less than -6, what happens? Your k values become what? It becomes smaller and smaller and smaller. So your values of k, all of them that are less than -6, are less than this actual value, which is 1/81. You can try 8, it will give you the same thing. You can try 9, it will give you the same thing. And -8, -9, I mean. So we can just say that k minus is just so this will give us 3 to the power 4. We'll determine that side. So we have 1/81. So just for standard, because we can just change this. So when you divide by -1, you invert the sign, because it's no longer the same now. I won't get into that. You can look at the why that is the reason that we change this, because we have divided by -1. Let's just cover the scope of functions, right? That's a different topic on itself. It's basic calculations, just like laws of exponents. So we've determined our values of k's. So the value of k for which you have values that are, for which you have roots that are less than -6 is k is greater than -1/81. So we know that so let me just do this. So this is just our thinking, it's not part of the answer that side. So let me just do another thinking here. So we want to see here, so this is 3 to the power x plus 2. We want to see if our value of k also include what? Also include 0, right? So which value of x will we put here to give us 0? There is no value of x that we can put to give us 0 there, to give us our y is equal to 0, right? Even if you put minus 2, you just have this 3 to the power 0. That's just 1, right? There's no value. So it means that our k values are greater than 0, right? Because we cannot find a k value that's about what? That's an x value that will give us a k value that's 0. So we can say k is less than k, we can just do this, is greater than minus 1 over 81, but less than 0. So this is our answer, right? So this was kind of we went to so many places before we got to the answer. So these ones are one of the questions that are most challenging when it is the last question. So it brings everything together and also brings concepts from different chapters, right? Because we have looked at the laws of exponents. We're looking at roads, a nature of roads, which is question 1 actually of this paper, right? So you never dismiss anything in mathematics. Everything can come on one can be tested. I mean, on one question, right? As we have seen here. So just a recap of what we did. We determined the horizontal asymptote. Each is the value that your function approaches but never actually touches, right? We looked that we found the coordinates of r, which is a y-intercept. We know that x is equal to 0, so we're already given this, and then we substitute this into the equation that we're given, which was x is equal to y is equal to a to the power x, and then that's a to the power 0 is 1. Anything to the power 0 is 1 actually. There are no exceptions. So we were asked to determine a. We did that. We found a to be 3. We determined the distance, dp. This is what we did, and then we looked at 4.5. We went there to find the values of k for which your roads or x values will be less than 6. And then we did these calculations. We found that your k values will be between 0 and minus 1 over 81. Thank you for your time. Let's catch me in the next video. We'll be looking at question 5 of this question paper, November 2016. Thank you.